And let's fire it away. You can see that it's going crazy. And we are at 1,000,000. How's it going, everybody? Welcome back to the channel. So I want to walk through a speed test of the RabbitMQ client versus the RabbitMQ stream client. So if you don't know what I'm talking about, let me pull up the code here. So in the last video, we went and looked at how to set up these two packages here inside of a .NET API. So again, we have a RabbitMQ client, which uses the AMQP protocol to connect to RabbitMQ. And also RabbitMQ has the RabbitMQ stream client, which uses their streams protocol to connect to a stream over port 5552. So I walked you through how to do that. So now what everybody's thinking, and because I couldn't help myself, is I want to do a speed comparison, speed test versus the queue performance versus the stream performance, because some people like to claim that RabbitMQ may, for whatever reason isn't fast, but I think that's just because people either don't know how to configure it or they just do, honestly, just weird stuff in the configuration or the consumer. So I want to show you how, if you really need very high throughput for your system, you can leverage streams with RabbitMQ. So I want to get into this right here. So queues are, let me go to my queue here, engine data. You can see that I've populated 1,000,000 messages ready to be consumed. And the same thing for my stream. I already had 5 messages in my stream and I didn't want to delete it. So we got 1,000,005, but for all intents and purposes, it's the same. Let me actually, I tell you what, for the sake of the video, I'm going to delete it. And I'm going to delete my engine data and I'm going to populate it. Well, I guess I'm going to purge the message here. So let's go refresh this and I'm going to populate my stream. So you can see it's going to rebuild just fine. Let's go back to my stream. You can see it's already been rebuilt. It's perfect. And watch, when I refresh, we're going to start seeing the message rate spike up like crazy. It's already at 250,000, 500,000. Give it time, it'll be at 1,000,000 very quickly. 750,000. And we're done. So again, within seconds, we've populated with 1,000,000 messages. And again, this is just on my local machine, which is a MacBook Pro with the M3 Pro chip. So this is just my local server, right? Local machine. If you have this thing on any kind of like performant computer or instance, you're going to see some serious speed. So that's the stream. And I'm going to go over to my engine data, I believe, and I'm going to populate this. So I do want to show you in the code before I do this. What I'm calling is, I have a couple methods here to populate data, and I'm sending the same message size of just hello world 1,000,000 times at each of these. So that's what I'm doing. So they're the same message size. So size isn't a factor here. Just so you're aware. So I am going to populate now the queue, and with queues you get a little bit more of like diagnostic stuff in RabbitMQ. So let's go ahead and look at this. So we get a basic publish per second rate. So looks like we're at 14.8 per second. We're at 29,000 per second. So it's moving pretty quick. A little bit slower than streams, a little bit, but it might be on par. It's very comparable write performance, as you can see. I should say that both of them are writing to disk. So I have the message properties for the queue writing it to disk, which is different. And I also, so it's not, they're not transient messages, they're being written to disk. So that's a non-factor as well. That might trip people up in if you're doing performance testing. But honestly, that one might have been the same performance as the stream. So you saw it live here, and you can make your own determination. But I'm going to count those as pretty much equal. And so again, they are the same message. And so how I'm going to do this for performance testing is very rudimentary. I'm just going to show you a consumer running. So I have two endpoints set up to call this get stream messages with stream protocol. And then it's literally just going to run through this and consume all the messages. And then I know when it's going to get to the bottom because I'm going to see my blank read line, and I'm going to count. I have this count variable that I have declared in each of the methods that I have going to be consuming from my both my stream and also my queue. So identical code. I'm not doing anything. I have the same write line statement as well. I will call out the fact that in the queue consumption, I do have to decode it, or encode it, I guess you should say, as UTF-8 from the message body. And I tried to do that in line of my console write line to avoid setting a variable to that, just to make it try, or at least try to make it a little bit more comparable in terms of how the stream is working with the message data. But again, I'm not doing anything else, and I'm just iterating through the count. So let's go and run these and just try to get a feel for how this is going to play out. So I'm not going to do any kind of, I'm not really going to set a timer, just because, well, I tell you what, let me, do we want to set a timer? I don't know. I'm just going to run it, and you'll get a feel for how this is. We're not being super exact on this channel. Let me show you how crazy this is, though. So I'm going to say this endpoint here is get stream protocol. We're going to get the messages from the stream. And I want to leave this here, and let's fire it away. You can see that it's going crazy. And we are at 1 million. I mean, that is just wild. And that's, again, on my local machine, how fast we consumed 1 million messages. Now, granted, we're not acting on the message. We're not doing anything beyond receiving it and logging it. But you can see how quickly, I mean, the throughput is insane, both writing and reading. Reading is faster than writing, but it's so fast. And again, let me go back to my Swagger docs, and I have my console read line. I just got space out of that so I can get here. And let me go to my get queue. Where is it at? Get car messages. Is that what it is? Yeah. All right. So now I'm going to do my get car messages, which is going to read the messages off the queue, and we're just going to see how quickly that does it. So, I set a breakpoint. Oh no. Did I do on the wrong one? Oh. Wait. Oh boy. All right. We're back. I had to change something in code. I forgot to await a task completed at the end of my message handler. So it was just stopping after the first consume message. So let me go back here and let me repopulate that queue. Okay, we're up to 1 million. All right, so now I don't have any breakpoints set. I'm going to clear the window, and let's go ahead and get those messages again. So you see it's flying through that. Honestly, it's like the same as the stream performance, which is crazy. Okay, so we got that. Let me get the stream one again. Get stream protocol. See, it's like the exact same. Do you see that? Which is insane. I mean, how many messages can we get populated on here? All right, so I'm going to kill out of that. So we saw the performance of a million, a million on both a queue and a stream. I'm going to, now that we have these ended, I'm going to populate my stream again. And let's add a million more messages to the stream. And while that's doing that, I'm going to populate the queue as well. Yeah, let's see if we can get, I want to add 5 million. Let's see if I can run, the queue is going to take a while. But we got both of these running at the same time. It's going to degrade the performance probably a little bit. What is my stream up to? Okay, 1.6 million, 1.7. I wish they had just like a consumption metric. I know they have the advanced runtime metrics, and you can change this to be maybe the moving average. What's current value? Current moving average. Maybe let's try that. Let's see if we get. I want to see if there's a reduction rate, but I don't know if that's. All right, so that's up to 2. Let's get that up to 3, and let's get more messages on my queue. My queue's at 1 million, so you can see we're at. RabbitMQ by default refreshes every 5 seconds, and so it's going to refresh incoming classic. The one thing I really like the RabbitMQ management client. It's very, everything's very straightforward. You know, it doesn't really add anything you don't need. It feels like everything's pretty much here. I will say there's some things that it lets you do that don't apply to in some cases. Like the UI will let you put like routing keys on a fan out exchange and things like that, but I would say the core functionality is definitely there, which is nice. So let's refresh this. So we should be able to populate my stream. Yeah, let's get him. I might just leave this at 4 million just for the fun of it. Oh, I opened my clock. I'm gonna set a timer, I guess, or not a timer, a stopwatch, I guess, for the for just consuming. Oh, you can't make it. Okay, well, I'm gonna leave a little stopwatch on the side here while I'm doing this. I do need to get my queue up to 4 million, so it'll be the same. And then I'm gonna run through this with my stopwatch. But I mean, as you can see, like working with RabbitMQ, apparently both streams and queues is ridiculously fast. I did read an article that said that somebody was able to get like 1 million message per second rate on a stream. I don't know how they were able to do that. I'm sure there's some configuration that I'm not doing to make it faster. And obviously I'm sure that's highly dependent on your machine. So, but just the performance on an M3 Mac is pretty wild. And honestly, like, it is tough to beat this level of performance in a local system. I mean, it's just as wild. And I will say it's interesting noting the performance difference of RabbitMQ's native client versus libraries. And, you know, anything that gives you that tighter control over configuration, I think is good, because you can get a little fine tuning out of this. And I will say that I have, I might turn off acknowledgements for this test, because that would impact it heavily, right? I have acknowledgements. I have it set to auto acknowledge. If I turn acknowledgements off, that would increase the performance. But I guess since my other tests weren't, I didn't have that. I guess I'll just leave it on. Because if you start messing with like the acknowledgments and the prefetch, you can also adjust the prefetch rates as well. Which actually that might have been. I probably should have messed with the prefetch rates, which that could be a different test because let me. Where am I going here? Populate. Basic consume. Maybe I should have did that actually, because you can adjust if you, well, not on your stream, but on your consumer. Yeah, I mean, there's a bunch of configuration that you can mess with. But anyway, I'm just going to leave it the default really. So I don't know if it'll tell you what the QoS value would be. Engine data. I don't think it would tell you. No. Okay. Oh, I should have said that also. This is a classic queue. If you're using a quorum queue, it's probably going to be a little slower. Classic queues are always going to be a little bit faster. So let's run this, I guess. And how we're going to do this is basically just have a window here. And I'm just going to be watching my console. And when it hits 1,000,000, I'm going to stop my stopwatch. Again, super rudimentary, but again, it's just the easiest. So I'm just going to get my queue first and then go from there. And I do want to delete the terminal window. Man, this is going to be tight here. All right, ready, set, go. Oh, geez. Oh, I stopped it. I thought it was, that was my bad. I think I might have just ruined the test. I just literally stopped it because I'm like, oh, it hit 1,000,000. I'll just leave like a little bit of time on. That's fine. Okay. Well, 22 seconds. Give or take a couple seconds. You get the gist. I stopped it at 1,000,000 because I'm like, I was thinking in my head, I'm like, oh, I only had 1,000,000 in there. But here we are. That's okay. So again, 22.5, 22, 23, whatever, around 22. I'm going to reset this, and then I'm going to do get stream protocol, which is going to do the use the streams protocol to get those. And let's go ahead and start this. I should have cleared the console or the terminal. Is this slower? Huh. Yeah, we're already over, and yeah, very interesting. Very, very interesting. I feel like there's configuration that, yeah, 34 something. So, I mean, about a 10-second-ish difference with, really? With streams versus like AMQP? Let me just see. Let me go down. So let's look at this code here. Get queue messages. I feel like and again, I didn't mess with the prefetch. I feel like this tells me that I need to mess with my stream configuration. Again, I was just following the documentation, but it was my understanding that streams are supposed to be very a lot more high, allow you to have a lot more high throughput of data on reads, and we're noticing about a 10-second difference consuming 4 million messages, which is like we're dealing with like 1,000,000 messages every 7 or 8 seconds. So Very interesting. Has anyone else done benchmarking locally in a .NET API? I'd be interested to know like what if it's a .NET client like discrepancy against like other frameworks that have the streams protocol library and also the RabbitMQ client library. But again, that's just a really basic test, and obviously my queue is down to 0, and my stream is obviously still 4 million. But that's interesting results. I was expecting the streams to be much faster compared to consuming off a classic queue. That makes me think I'll have to go back and really see if I can dial in the configuration. But honestly, that poses a challenge to me on the channel to try to dial in my stream configuration to see if I can crank that number a lot faster than my queue consumer. So this has been really informative for me. And yeah, so that's just a rough speed test of a .NET API with 2 endpoints, one hitting a classic queue and one hitting a stream with the stream protocol. So thank you all for watching, and I will see you on the next one.